Hi, this is JP from Pilz Automation Safety Canada. I'm about to show you how to create a simple project in a PNOZmulti Configurator. So, first of all, whenever you open a new project on PNOZmulti Configurator, this is the screen you get. As you can see on the left side, the first thing you have to carry out to complete in the project is the hardware configuration. And as you can see on the left side, you have different units that you should select. So the first thing you should select is the base unit. So you have different base units. You have generation 1, you have PNOZmulti Mini, and you have the PNOZmulti 2. So more and more we are working with PNOZmulti 2, but it depends on your hardware essentially. It's very easy. You just have to drag and drop. So for this example here, I will use a base unit is MB0. Okay. And then I just drag and drop to this side of the screen. And as you can see, you have your base unit added to your hardware configuration. Now, there are more details here. Whenever you click on a module on the left side here, you'll get more information about the product. In this case, it's the base unit. Anyway, you can also, in the bottom side of the screen, you can um, edit some information here. So it's very important that you always use the proper version of a hardware. So the hardware, typically when you go in front of a unit, you have this three numbers here, as you can see. So this first number would be the part number of the product. The second, the smaller number, would be a serial number. And on the side of a serial number, you have a hardware version. So it's important that the hardware version here matches the reality. So if you have hardware version v2.5 and you select, let's say, v2.0 here in the software, it's probably not going to work. So good idea is to always check if a hardware version is the same. Now, one other thing you can do is to change the equipment identifier. That would be, let's say, the identification tag of the base unit on your wiring diagrams, for instance. So let's say you have uh, minus 8A20. Let's say that would be my equipment identifier. Okay, so from now on in my system, in my software, in my hardware configuration, my equipment will be called minus 8A20. You can also add more information like a location description. So you can put more information here. For instance, +05. It depends essentially on your wiring diagram. Here you see that you have 20 inputs available and 4 semiconductor outputs. That's what this base unit will allow you to have. But as you can see here on the left side, you could also add some more I/O modules. So you have 16 digital input fail-safe input modules. You have 8 digital input and 4 digital output modules. You have many different versions of expansion modules. What you have to consider is that there's a limited number of inputs and expansion modules that you can. It depends essentially on your hardware, but the software will guide you on the maximum number of modules that you can expand to the right side of a module. Now, to the left side of a module, you could also use some field bus modules, as you can see here. So you have different protocols that you can use. So, for instance, if you need to communicate with different PLC, with a standard PLC that has that has a certain field bus protocol, like Siemens, you may have Profibus, then you could add the field bus modules. Just a matter of you adding the module to drag and drop the module here. We don't want to do that for this presentation. It's just a simple presentation for a simple project, right? So yes, this is the first step. So you have to define your hardware configuration. Now, once you have your hardware configuration complete, you need to change your program. So let's go back. When you click on the tab User Programs, this is the screen that you get, right? So you have 1, 2, 3, 4 rows and 1, 2, 3, 4, 5, 6 columns. The left side, the leftmost column is for input elements, and the rightmost column is for output elements. So let's see an example. What kind of elements should I use here? So PNOZmulti Configurator works with blocks, right? So you just add the blocks, and the blocks have their functions. So if you go to the right side of the screen, you see the function elements. You have different function elements such as e-stop, safety gate, light curtain, two-hand control button, enable switch, operating mode, selector switch, and so on. You have many different function elements here. You have also some logic elements that you will use to create your own logic function. There are press elements for some functionality. We're not going to explain the press elements in this presentation, but if you want to know more about this, you can go to our help file, and there are lots of information that will guide you on the blocks for press elements. As for miscellaneous, you have many other functions. So cascading element is not going to work for generation 2, it's just for generation 1. You have safety net when there are a couple of modules that will have safety net. You have start element, you have time element. There are many different things that you can use with the miscellaneous blocks. You have diagnostic elements that you could also use. Burner when you have burners, but in this case it's also something you should look into the help file. And output elements, and also the connection points. So let's see every function element. So first of all, you have e-stop. When you drag the e-stop and you drop on a leftmost column, so you could select any row here. So the block for e-stop will require some setup, some configuration. So first of all, you have to define if your e-stop is single or double channel. So in this case, you have three options. You have single channel, you have dual channel, and you have also dual channel with simultaneity. So typically, we have most of the cases we have a dual channel e-stop. So you could have two options. You can have test pulses. That means when you need higher diagnostic coverage, you need a higher monitoring on e-stop. You may use a test pulse. So test pulse is you have in a PNOZmulti you have four test pulses. So you have test pulse 0, 1, 2, and 3. And those test pulses, they're time shifted. So if there is a short circuit between the channel 1 and channel 2 of the e-stop, the PLC will detect immediately, because it's really unlikely that the test pulses will be at the same time at the same state. So yeah, this is a good. So this is very important when you have Cat4 architectures, right? You need test pulses. When you have, let's say, Cat3 applications, you don't really need test pulses. So for this exercise here, I'm not going to use the test pulse. So I can define the equipment as we have defined before. -8A20 is the equipment ID, and this is the inputs. So IM0 and IM1 is input 0 and input 1. So the inputs that have this description, this designation IM, those inputs are also configurable as outputs. So there's a way you can configure this inputs here as outputs. So when you have those inputs can be configured as standard outputs. Let me clarify this, because you can either use those inputs as safety related inputs, or you can configure those IM input outputs as outputs, and then they become standard for standard purpose elements. So we'll see how it works. So yes, I have two different inputs here, IM0 and IM1. I could choose freely. As you can see, I4, I6, I5, I6 through IM19. So all of the IM inputs are configurable as also outputs. So we'll see how that works later. In this case, this Cat3 architecture, we don't really need the detection of shorts between contacts. Therefore, I just have to define, well, do I need a reset, a monitored or manual reset? So monitored reset is a type of reset that you have to, you need a transition from low or high logic level to low logic level. And a manual reset would be the transition from low logic level to high logic level. Or you could also have just automatic reset. That means you don't really need to use a reset. So it's up to you to define what kind of reset you'll have for the block. So let's say we use a monitored reset. And then you have to define what is the input that you will use for reset. So the recommendation directly here is IM2, but you could also select freely the input that you need. Anyway, general. As for general, you can also add here some ID for the block. So I will say ES1. That will be my e-stop block identification in this case. So I just go and click on OK. As you can see, this is the block that you get. So ES1 is the block. There are more information here. So you can see the inputs that are being used, right? And now what you have to do is to link this to something here, right? So now you have to define what are your outputs. So let's say I have an output. So if you go to output elements, I have semiconductor output here. Just have to drag and drop to the rightmost side, rightmost column of the screen. Now this is the screen you get when you have to set up the semiconductor output. So first of all, you have to define if you're using the output as if it's a safety related output or is an output for standard functions. So as I told you before, the IM input outputs can be freely configurable. So if I choose output for standard functions, then you see that you can only select those outputs here. Okay, so if I select IM3, I'm now defining IM3 as an output, and this output will be for standard functions, not safety related functions. And this standard function and the max current of such an output is a max current of 75 milliamps. So it's not for many applications. So let's say you want to just send a signal to a PLC and for an input of a PLC, so that could be the case. Okay. Now, when I use safety related output, I can only use from E0 to from O0 to O3, which are the semiconductor safety related outputs. And now you have to define if the output you're using is a single output, so that means you have only one channel, or if you need a dual output. So it depends on your application, of course, right? So you could use just a single output to switch to different contactors. So you can reach a PL of up to E and Cat4 if you're using that in the same control cabinet. Yeah, it depends essentially on your wiring. And I have to remind you that you should always have qualified personnel to program and to install and commission all of your safety related functions of your machine. Okay, this is a very important disclaimer that we have in this video. So sometimes you need a feedback loop. So especially for Cat3 and Cat4, you need a feedback loop. And yeah, so I have defined as a single output feedback loop. It's a safety rated output. And I can also define the ID for the output block. So let's say this will trigger contactor 1, contactor 2.